type of heat transfer that we're going to talk about today is called conduction. Now, what we mean by conduction is heat transfer through direct contact or by touching certain objects. For example, if you've ever burned your hand on a hot pan or something warm on the stovetop, because you are burning it through directly touching the pan, that would be heat transfer through conduction. So here we're going to demonstrate how conduction actually works. How does heat actually get transferred through direct contact? And what we're going to do here is we're going to look at what happens when I heat up this piece of metal and what happens when we interact it with these candles. Now obviously right now this is just a regular room temperature piece of metal. It's not very hot. I'm clearly not burning my hands. And obviously this candle's pretty solid, right? So as you guys know, candles have specific characteristics when they get hot. So we're going to heat up this piece of metal and I'm just going to hold it on top of this candle and we'll see if there's any kind of heat transfer. So I'm just going to leave this metal rod on the Bunsen burner for a couple minutes. Alright, so that's probably been long enough. Let's take off this piece of metal, if we can get it off nice and carefully here, without hurting myself. And let's see what happens when we try and interact with this hot piece of metal in our candle now. As you guys can see, I am melting straight through this candle, kind of like I'm cutting through butter. Now, I'm not really putting any pressure on it, but as you guys can see, we get some steam here because I'm burning all the wax. And I only cut through the center because it stopped me once I got to the wick. I could probably cut the other half, but I don't really want to touch it because it's probably pretty warm. So as you guys can see, I melted straight through this candle, right? The heat was transferred directly from this metal rod to the candle wax through conduction because they were directly in contact with each other. One of them was touching the other one. The next type of heat transfer we're going to talk about today is called radiation. And radiation is the heat transfer through empty space. So a couple good examples of this are if you've ever seen a picture of a space heater, something like that drawing that we have here, or if you've ever used one of those in your house. Sometimes they're also called radiators. The reason they're called radiators is because the way that they transfer heat through the room is through radiation. Another good example of radiation is standing in the sunlight, right? Obviously it's much warmer in the sun than it is in the shade. And the reason for that is because you're getting more heat transfer from the sun that travels through space and ends up hitting you with sunlight. So now we're going to move on to looking at a demo that demonstrates how heat's transferred through radiation. Now, I have a little bit of things going on right now, so just as you know, this is a piece of metal. I'm just using it as a stand for now, but I just wanted to show you that it's cold enough at room temperature, at least at this point, where I can put my hand on it and it's totally fine. Okay? Now I'm going to be using this glass dish. Hopefully it's easy enough to see there. And I'm going to take this stick of butter and I'm just going to set it in this dish. So here's our solid chunk of butter. It's just sitting in this dish up here. And what I'm going to do is I'm going to kind of angle our Bunsen burner near the flame or near the butter. But we don't want the butter to actually go in the flame. We just want it to be near the fire and see what happens in that general area. Okay? Because radiation is all about heat transferring through space, right? Not by direct contact. Not by things touching, just by things being in a good enough area where they can absorb some heat, just like if you were standing in the sunlight out on a summer day. So let's leave this set up here and see what happens over a little bit of time. All right, so we're going to stop there. Obviously, the stick of butter still exists, but hopefully this glass isn't too hot. And if you look carefully, you can see that we're getting a little pool of butter right here. You can see that there's some actual liquid in here. Now that's a good indication that this butter has softened up a little, because it's been absorbing heat from the flame in the Bunsen burner, and you can see that we're kind of getting some melting right around here. So obviously this is still a solid piece of butter, but over in the corner, we are starting to see some melting. Right? That's what's given us this puddle here of oil or butter. So don't let radiation fool you. It may seem to be a pretty slow process, and there might be a pretty significant difference between standing outside in the shade and standing outside in the sunlight, especially during the summer. But you can still get a sunburn from standing out in the sunlight, even if it doesn't feel very warm. So although radiation may take longer and it's slightly less effective, that doesn't mean that it's not good at transferring heat and that it still can't get the job done, because obviously it can. Now, I probably could have used a smaller piece of butter to simulate that, but this is the only butter I had. The last type of heat transfer we're going to talk about today is called convection. Now, convection is heat transfer from one place to another through the movement of gases or liquids. So some good examples of this are lava lamps. We've already talked about how this happens in terms of the Earth's mantle. Remember, it has to do with hot magma rising up towards the surface of the planet, and as it cools, it falls back down because its density increases. So that's what we were talking about in an earlier unit this year, talking about how there's convection currents in Earth's mantle. This is also why we see cigarette smoke always rises. If you've ever seen a person walk by with a lit cigarette, you never see the smoke going down towards the floor. Well, why is that? That's because convection causes warmer things to rise higher in the air, so we always see smoke go up because smoke is warm, as opposed to falling if it was cold, which obviously isn't the case. So what we are seeing here is the globs of wax in the lava lamp are continuously going up and down inside the lamp. The reason this is happening is due to the process of convection. At the bottom of the lamp there is a light bulb, and the light bulb heats up the wax that sits at the bottom of the lamp. As the wax heats up, its density decreases because the molecules of wax are moving faster as they heat up. This causes the wax to rise higher in the liquid as the density changes. However, as the wax moves up in the lava lamp, it gets further away from the light and the heat at the bottom, so its temperature starts to go down. As the temperature goes down, the molecules stop moving so fast and the density of the wax increases, causing it to fall back down to the bottom and sit on top of the light bulb where it can heat up again and start the process all over again.